What's up to you all awesome Mindsetters? We missed you guys. My name is Abram and welcome to Learn Extra. It's been a while, guys. It's term 3 up with a bang. I hope you guys are ready though. It was your first day at school today. I'll chat with you a bit later just to find out how was your day. But on this show, we do have Natasha. Natasha, how are you?
I'm very well, thanks, Abby. It's great to be back first day of the term. I hope you guys are all ready to work.
I hope so too, and I've been getting some feedback from Facebook. The Mindsetters say they can't wait for this term. It's quite a short term as well. It's not that long. I hope that you guys are ready for it. But what are we doing today?
All right, guys, so today we're looking at geometry again. If you guys were paying attention in the last term, and I know you all were, we did cover geometry. We looked at quadrilaterals, and we also did a bit of midpoint theorem. And today we're revisiting that. So we're looking at applications of your midpoint theorem and your properties of quadrilaterals.
Nice one. Well, we've got also exciting news for you guys. We've got an awesome competition that we're running through our Test Yourself questions. All you need to do is to go to facebook.com/learnextra, like the page, share the page, and engage on the page. Share with all your friends what you understand about what we're doing today and help other Mindsetters on the page. Otherwise, follow us on Twitter @learnextra. And remember, guys, we do post the links, the link notes for you on Facebook, and the Test Yourself links on Facebook, which have a code. If you get the Test Yourself questions correct, you stand a chance of winning this awesome Casio calculator, proudly sponsored by Casio. I'm sure that you're doing it, this calculator. But it doesn't end there. We do have the Nokia mobile mathematics app, whereby if you go on it, challenge yourself and challenge other Mindsetters, rank yourself on it, and you could be just great also in your mathematics. Your code for that is 2FB5. 2FB5. So I'll post the links also on Facebook. So guys, chat with me on Facebook. I'd love to find out how are your holidays. Share with me and I'll tell you also what we've been doing over the holidays. Natasha, back to you.
All right, well, hopefully you've had some time to sneak in a bit of revision, hey, in the holidays. Abram?
It's been hectic, eh? We've been doing revision up until yesterday. So I hope the Mindsetters were following us and they were doing what we were doing too.
Fantastic. Well, if you have been revising, then guys, this is going to be easy peasy for you. You're going to remember all of the geometry you've learned, your quadrilaterals, midpoint theorem, and we're going to combine it to help us get through today's lesson. I just want to remind you of the challenge question. You are given ABCD as a kite, and you're told that AD is equal to AB and CD is equal to CB. All of that is on your diagram ABCD. You're then asked to prove that angle ADC, so that one there, angle ADC is equal to angle ABC. And then part B, prove that diagonal AC bisects angles A and C. So prove that C1 is equal to C2 and that A1 is equal to A2. Now guys, what some of you will realize is that really what I'm asking you to do here lends itself to the properties of a kite. Because remember, in a kite, you have that the opposite angles are equal. Okay, the angles opposite the two included equal sides, and then you also have your diagonal bisecting your interior angles. All right, so it is a proof, it is a theory that you learn, but now we're asking you to show that. So remember, you can't say that because it's a kite, these properties hold. You actually have to prove why these properties are true. Okay, so that's what we're asking you to do here, is to prove that these properties are in fact true for kite A, B, C, D. All right, and then just a reminder of what we're doing in today's lessons. We're looking at the midpoint theorem. Remember, the midpoint theorem states that the line joining the midpoints of two sides of a triangle. So let's draw our triangle. And you've got a line going like that. So the line joining the midpoints of two sides of a triangle. All right, so that's our line there. It is parallel to the third side of the triangle, and it's equal to a half the length of the third side. So if this, for example, is x, then that would be a half x. All right, so we're going to draw on that knowledge of the midpoint theorem in today's lesson. Properties of special quadrilaterals. All of these need to be understood and applied. I'm not going to go through all of them again because we went through all of this in detail in the previous term, so I'm assuming that all of you guys understand the properties of your quadrilaterals. You know what a kite is, you know what a rhombus is, rectangle, square, all the rest of it. Today we're simply going to apply those properties, okay? All right, so let's get straight into it with question 1. You're given two right-angled triangles, and you're asked to find x and y. So these are your two triangles. I'm going to name them to make it a bit easier to identify. So we'll call the big one ABC, and let's call the little one D, E, F. All right, for some reason I can't write beyond there, but that is supposed to be a C. Okay, and we are supposed to find x and y. Now remember, guys, they also tell you that these two are right-angled triangles. So therefore we know that that's 90 degrees there, and that's 90 degrees there. Remember, when you look at 90-degree triangles, your right-angle triangles, you need to start thinking of certain things. For example, whenever I see a right-angle triangle, the first thing that springs to mind is the theorem of Pythagoras. And so we need to look for ways in which we can use that theorem. Okay. Now, we are asked to find x, right? But we can see that side BC is 2x. So therefore, if I found side BC, I'd be able to find x, which is length, EF. How can I find CD? By using exactly what I said you should be thinking about, theorem of Pythagoras. So we've got AB is your hypotenuse. Remember, your hypotenuse is the one opposite your 90 degree. And we've got the shorter side, AC. So therefore, if I'm looking for BC, I can say, using Pythagoras, all right, for some reason I'm going to have to go way down here. I cannot seem to write anywhere on this page. There we go. Maybe we can find a space there. There we go. AC squared is equal to, so AC squared, sorry, plus BC squared. That's what we're doing. We're writing down the theorem of Pythagoras. AC squared plus BC squared, the sum of the square on the two shorter sides, is equal to the hypotenuse squared. So therefore, if I'm trying to find BC, BC squared is going to be equal to AB squared, which was 25, minus AC squared, which was 15. All right, you can then enter that into your calculator. So we've got 25. All right, nothing seems to want to work today. I think it's because it's the first day, so everything's going a little bit pear-shaped.
I think you need to click on the, there's a checkbox there on
A
your
check
left, far
box.
left, on top.
Turn
And
on.
yes.
Let's turn off. Hey?
Yes.
There we go. Hopefully that does the trick, Abraham. There we go. Yes. Okay, so 25 squared. See, as I was saying, nothing wants to work today. What is going on? 25 times 25, let's do it that way, minus 15 squared, so minus 15. Nothing's really working today, Abraham. It's going to be a long, long day. So we're going to get that's equal to 400, right? BC squared is equal to 400, so therefore BC would be the square root of 400, which is 20. Important, guys, remember, if you've got BC squared is equal to a square number, you need to square root to get the length of BC. So therefore BC is going to be 20. All right? And we know that BC is also equal to 2x. So therefore 2x is equal to 20. So that means that x must be equal to 10. So that's our value there. And we found that x is equal to 10. We now need to find y, guys. But if you look at what you've got so far, do you have enough information to go straight into triangle DEF and work out the length of DE? Because all we've got so far is simply that x is equal to 10. So if we've only got this one side, there's not enough information just within that triangle to help us get the length of DE. So what we do is, if you look at triangle ABC and DEF, they look suspiciously like similar triangles to me. So all we're going to do is show a little bit of working. We can see that in triangle D, they've marked DEF. They've marked angle D as 35. Angle F is 90, and therefore we can work out, using angles of a triangle, we can work out that angle E would be 90 minus 35, which is 55. So angle E is 55, and we can see that in triangle ABC, angle B is also 55. So that implies that angle A, using sum of angles of a triangle, must be 35. And remember, what do we call triangles that are equiangular? Okay, equiangular triangles, we call them similar triangles. Hopefully you all know that. Equiangular triangles, another way we can say that is that these two triangles are similar. Now, when two triangles are similar, you get proportions. You get the fact that the sides are in the same ratio. Therefore, using my similarity, we can say, well, triangle ABC is similar to triangle DEF, and I'm going to write this little part down now. This is part of our calculations. Triangle ABC, remember with similarity, your order is very important. So if I've gone ABC, triangle ABC, that means I started at 35 degrees, and then I went to 55, and then I went to 90. So I do the same thing in triangle DEF. I go from 35 to 55, and then to 90. So therefore, it would be similar to triangle DEF, and the reason for that is they are equiangular, so we show that all the angles were the same. All right. Therefore, following from that similarity, remember the side that you're looking for here was side DE, okay, that one. And the side that we've got is side FE, that one. All right, so using proportion, I can say that AB over BC is equal to DE over EF. Guys, this is nothing new. This is similarity that you've learned before in previous terms and even in grade 9, so you guys should all be familiar with this. Once I've got this proportion set up, that follows, because the triangles are similar, remember, I can then put in the values for AB and BC. AB was 25 and BC was 20. All right. We are looking for DE, which is the same as Y, and we know that EF was 10. Then simply by cross multiplying, I can say, well, 20 times DE is equal to 10 times 25, 250. Therefore, DE is going to be 250 divided by 20. All right, so let's just have a look and make sure that is correct. It was DE that we were looking for, and we had FE is 10. Correct. So therefore, let's have a look. We've got 250 divided by 20. Hopefully our calculator's working. And we get an answer of 12.5. So therefore, DE is 12.5, which means that Y is 12.5 because Y was equal to DE. That was given. All right. Okay, so that's really just an application of similarity and then also the theorem of Pythagoras, because remember in geometry, everything you've learned in previous grades, you've got to remember because it can be tested at any point in any grade from grade 9 onwards. Okay, so don't forget all of that information that you've learned so far. Okay, I think it's a good point to take a break.
Yes, it is. And a big shout out to the man-sitters that are chatting with me on Facebook, such as Setu Nemea watching with Zakele saying we enjoy the show, and also Moyahabo Mahato Mahato, who's tuned in. Welcome, guys, and to all the other mindsetters that are tuned in. Remember what Mahatma Gandhi once said, that live as if you were to die tomorrow and learn as if you would live forever. Well, on that note, we'll see you guys after the break. Remember, during this break, you have the challenge question. Welcome back, Mindsetters. Now, more exciting news are we have an awesome competition, which is it's called the Water Game. It's a serious water game, and we've got exciting prizes for you guys. It's all about building awareness on water conservation and also saving water, and building a community that is saving water and all other natural resources, but particularly water. Well, we've got prizes such as first prize, it's 5,000 Rand up for grabs. Second prize, it's 3,000 Rand. And third prize, it's 2,000 Rand. For more details, are on Facebook. I'll share it with you guys on Facebook, but you need to go to watergame.co.za and also hashtag SA Water Game. It's such a great concept, also challenging the mindsetters in terms of knowing what's happening around them, saving water, which is a very, very good concept, don't you think?
Absolutely, absolutely. Water conservation and also environmental projects, I mean, definitely a good idea. And I mean, also, the money involves, fantastic initiative as
exactly. Well. That's my thought, that why are we doing this in an exciting way? Because I know that the mindsetters need to challenge themselves as well, and then not just get things easily so, but you learn at the same time. It's a game, but it's a serious game that you need to be learning and yet playing at the same time.
Absolutely, so, and it also sounds like it's going to be testing you guys' logical reasoning, deductive skills. So there's also a bit of maths involved. You know, maths is involved in everything. You can't get away from it. So it's a great idea, and hopefully everyone gets involved. So, Abby,
please, guys, register right now. More details are on Facebook. Remember, the website is watergame.co.za, and also on Facebook, hashtag SA Water Game. Back to you, Natasha.
All right, so guys, we're going to carry on with the more deductive reasoning and logical thinking like you will do in your game. We're looking at question 2, and in this one, we've got a diagram where they told us that PQ is equal to PF, and FG is equal to QR. They also tell you that FG is parallel to QR. Angle P is equal to 50, so I'm just marking all of this given information on our diagram, and angle S is equal to 40. They ask you to find the value of X, which is all the way in that corner there. All right. So, guys, from looking at the diagram, you've got to already sort of conceptualize and think about what is your plan. How are you going to get to X, which is here? It looks almost unrelated to anything else. And you've got to sort of then work backwards. How will you get to X? Well, you could get X if you had angle G, right? To get angle G, you could get angle G if you perhaps had angle F, or the one right next to you if we called it G1 and G2. There are different ways to get to G, and we could perhaps get this angle here if we worked out this one and this one. So we sort of work backwards and we see, well, let's look at the information they've given us and decide how can we get to this little one in the corner here. And obviously the only way to get there is to relate that angle to other angles on your diagram. All right. So I can see that in order for us to get to X, I'm going to need to either find, if this is G here, I'm going to call it G1 and 2. I'm going to either need G1 or G2. And to find G1 or G2, I'm going to need either F1 or F2. All right. Now I can see very easily how to work out angle F1 because they've told us that PQ is equal to PF. So straight away I know that's an isosceles triangle. We also know that angle P is equal to 50 degrees. So therefore, I can say in, all right, and we've got a little blockage there, so we're going to move to the corner here. We've got in triangle PQF. Because it's an isosceles triangle, I can say that angle P, which was equal to 50, is going to be, okay, let's set out the whole thing. Angle P plus angle Q1 plus angle F1 is equal to 180 degrees, and obviously your reasoning there is sum of angles of a triangle. All right, and we know that it's an isosceles triangle, so therefore Q1 must be equal to F1 because we have an isosceles triangle. So therefore I can say Q1 is equal to angle F1 because you can state your equal sides, or we can simply say isosceles triangle. Therefore, we know that angle F1 is going to be equal to 180 degrees minus 50 divided by 2. Okay, so I've done a couple of steps in one in there because I said Q1 is equal to F1, so therefore I'm saying angle P plus angle F1 plus angle F1 is equal to 180. So simply to get angle F1, I say 180 minus 50 divided by 2. 180 minus 50 is 130 degrees divided by 2. That will give me 65. Okay, so I can go back up to my diagram and I know that F1 here is equal to 65 and Q1 is also equal to 65 degrees. So we've got F1, we've got to try and see now how can we get all the way to angle G1. If you have a look at your little quadrilateral FQRG, so look at this quadrilateral here. FQ, right, the one that I've just highlighted there in pink. Well, as far as the board will let me highlight. So we've got FQRG, right? You can see that you've got one pair of opposite sides being parallel and equal. So therefore, straight away you should start thinking about properties of a quadrilateral. Remember guys, there's all these properties you know of a parallelogram, and there's different ways to prove that a quadrilateral is a parallelogram. One of those ways is to show that one pair of opposite sides is both parallel and equal. And here we don't even have to show it, it's already been given to us, so we can simply state it. So we can say, since we have, alright, so since FG is equal to QR and FG is parallel to QR, I can say therefore FGQR is a parallelogram or a palm, if you want to abbreviate. And your reason for that is we have one pair of opposite sides parallel and equal. Okay, why is it necessary for me to show that FGQR is a palm? Well, once I've shown that that shape is a palm, I then automatically deduce that GR must be parallel to FQ. And that's important because when I get parallel lines, I have all those exciting angles that we can use, hey? Corresponding co-interior and alternate angles. So therefore, if I've just worked out F1, which I have done, so I've just got F1, I can then work out that G1 must be equal to F1 because those are corresponding angles. So that one must be equal to that one because those are corresponding angles. So you have that little F type of shape happening there. Okay. All right, so therefore angle G1 is going to be equal to 65 degrees. So we can say angle G1 is equal to angle F1 is equal to 65 degrees. And the reason for that is corresponding angles. Okay, and then because we have G1, right, so in this triangle we've got, in this quadrilateral, we've got that angle G1 is equal to 65. Okay. Now I'm getting closer to working out angle X. All right. Do you see that, Abram? Mm-hmm. Are you sure? All right. We're getting closer to working out angle X because we have this triangle GRS, right? So therefore, I can say that that angle G1 is the exterior angle of triangle, and obviously I love lots and lots of color. When you work with geometry, it's nice to work in lots of different colors. That angle is going to be the exterior angle of triangle GRS. So therefore we know the exterior angle is equal to the sum of the interior opposite angles. All right, so therefore we can get to x. So let's set that up. We can say angle G1 is equal to angle S plus angle X. And the reason, remember in geometry, whenever you make a statement, you have to give a reason. Exterior angle of triangle. We know that S is 40. We know that G1 is 65, is equal to 40 plus X. So therefore, angle X would be 65 minus 40 degrees, which will give us 6 minus 4 is 2, which will give us 25 degrees. So therefore, angle X is equal to 25 degrees. All right, but hopefully what you guys picked up there is that it was quite a lot of sort of intertwining and linking of a lot of different sections that you, or a lot of different properties you've learned before. We've had an isosceles triangle thrown in there, properties of a parallelogram, exterior angle of triangle. You had to combine all of that information in order to get to this little angle X. So nothing that you learn in geometry is ever learned in isolation, and that's what I'm really trying to stress to you guys. Okay, hopefully you're all following me. AB, is everyone following on that side?
They are.
All right,
So
great.
far, so good.
All right, so shall we move on to question 3?
Yes.
Okay, guys, so let's have a look at question 3. So here we've got another quadrilateral. You are told that triangle PQR and triangle PSR are equilateral. Remember, in equilateral triangles, it means that all the sides of your triangle are equal. Prove that PQRS is a rhombus. Now, obviously, firstly, you need to understand what the properties of a rhombus is. You need to know what the properties are, so that, or you need to know what a rhombus is in order to answer this question. Obviously, if you don't know what a rhombus is, that means you need to work a little bit harder on your theory, and you need to learn the properties of rhombus, kites, etc., etc. You need to learn all of those. Okay, so we're asked to prove that this is a rhombus. Now, one of the defining things is, remember, a rhombus is a palm, okay, which means you're going to have opposite sides being equal and opposite sides being parallel. Okay, so a rhombus is a palm. But the thing that's special about a rhombus is that all 4 sides are equal. One of the defining properties. So all 4 sides are equal. And remember, you can use any of the defining properties to show that the shape is the special shape that they are asking you to prove. Okay, so all 4 sides are equal. Another special thing about the rhombus is that the diagonals bisect the interior angles. Okay, so if you can show that, then you can show that it's a rhombus. Also, the diagonals bisect each other at 90 degrees. And all right, so that's all I can think of now, guys. Hopefully, if you're sitting at home, you can fill in whatever ones I've missed out. But so far, with those 3 that I've got there, if I can show that any one of those properties is applicable to this quadrilateral PQRS, then I can show that this must then be a rhombus. Okay, but your starting point here is to first show that it's a parallelogram, because remember, that's where all your definitions will take place for your special quadrilaterals, right? You need to prove something else and then get to what you want to show. So here I need to prove first that it is, in fact, a parallelogram, because at the moment all I see is a 4-sided shape. All right, they've told you that PQR and PSR are equilateral triangles, and that's the only information you've been given. So what that means is PS must be equal to PR must be equal to SR, because it's an equilateral triangle, right? Remember, another special thing about equilateral triangles is all the interior angles there we go, all the interior angles are 60 degrees. Okay, now if you look at side PR, it's common to both triangle PSR and triangle PRQ. So therefore, PR is going to be the same length as PQ, which is going to be equal to the same length as RQ. So therefore, we can see all four sides are equal, but we cannot make the statement immediately that it is in fact a rhombus. Okay, let's investigate a little bit further. We know that because PQR is an equilateral triangle, all of the interior angles will be 60 degrees as well. All right, so angle Q there would be 60 degrees as well. Okay, so first step, let's state why this is a palm. I'm going to use the most basic way to prove that something is a palm. We're going to say opposite sides, both pair of opposite sides are equal. So since we have SR is equal to PQ, and the reason for that is they both are equal to side PR. Right, it's the common side. So since SR is equal to PQ and side PS is equal to side QR, therefore that implies that quadrilateral PSRQ is a palm. And the reason that it's a parallelogram, because we've got both pairs of opposite sides equal. So both pairs of opposite sides are equal, therefore we can make that statement. Once we know that it's a parallelogram, then obviously we know other things, like for example, PQ is parallel to SR and RQ is parallel to PS. Okay, so now we know that it's a palm. The next thing we need to show is that it is in fact a rhombus, and in fact the work has already been done in our explanations. Okay, the way we got to the fact that this is a palm, we've actually sort of already proved it. So what I'm going to go for here is, if we can show that all four sides are equal to each other, then it is in fact a rhombus, because it's a palm with all four sides equal to each other. So it's a rhombus. Okay, so how do I state this now? Well, I need to state why all the sides are equal to each other. So I can say, well, PS is equal to SR is equal to PR, because it's an equilateral triangle. All right, and PR is equal to RQ is equal to QP for the same reason. It's an equilateral triangle. All right, so it's the same reasoning. Therefore, it means that all the sides are equal to each other. So therefore, we've got all four sides equal to each other. So therefore, we've got PS is equal to SR is equal to RQ is equal to QP. Therefore, that means that PR, let's just get the PSRQ is a rhombus, and the reason for that is all four sides are equal. Right. So it's a rhombus, all four sides are equal, and we've shown that, so therefore that must be a rhombus. Now guys, remember, don't confuse a rhombus with a square. The difference between a rhombus and a square, in a square also, yes, all four sides are equal, but in a square, all your interior angles are in fact 90 degrees. And in a rhombus, the diagram almost tilts a little bit, so it looks more like a diamond kind of shape if you want. So therefore, you can distinctly see the difference between a rhombus and a square. So in a square is a right shape. So in other words, all the angles are 90 degrees, whereas in the rhombus, it's at a slight slant. All right. Okay, let's go to a break.
Right, thanks, Natasha. Well, I'm so glowing right now because of the great news that I've been hearing from the Mindsetters, that they've got exciting news, but I'll tell you more about them after the break. But in the meantime, a big shout out to the friends and Mindsetters that are watching, such as Lutando, who's watching. More shout outs are coming after the break. Don't move. Welcome back, awesome great talents. Now, Benjamin Franklin once said that, tell me and I forget, teach me and I may remember, but involve me and I will always learn. Talking about mindsetters that were being involved, here's some great news, Natasha. First one is from Maxwell Kile Simanga. He says, really loving my Triple M day. Math has never been so easy. Thanks to you guys. Love you guys lots. But I got my maths 93%
Wow.
and physical sciences 89%. And all thanks to Mindset. Bless you. Thank you so much, Maxwell. And it's all our wonderful teacher.
Yeah, wow, that's amazing, Abby. I'm so excited. I'm glad that you guys are doing so well, and I'm glad that the show is helping everyone, because that's what we want to hear.
Exactly.
Hey,
You must
fantastic.
involve yourself. As much as we give you guys the knowledge, you must also play your own part. Last one, Natasha. Gift Neo Smith says, thanks to Mindset for the support. I excelled very, very good. With my maths, I got 91%.
Wow.
Physical sciences, 88%, and life sciences, 85%. Thank you to the Mindset Tim. I love you all. Thank you so much, Gift. And yeah, it's all the effort that you've put in also as well. So big ups to you and congratulations.
Yes, I think so. I think well done. And, you know, it's obviously, I'm glad that you guys are getting so much out of the show, but I'm also glad that you're working hard, because if you just watch the show and don't work, you're not going to get marks like that. So well done to both of you that let us know.
Nice
and guys, I think it is time for us to get on to the challenge question, so we can do it before we run out of time till the end of the show. Okay, so hopefully you've got some answers and you've been chatting to AB and giving him some ideas of what the answer is like. All right, so here we are told that ABCD is a kite. You've got all your equal sides down on the diagram. AD is equal to AB, CD is equal to BC, and you're asked to prove something that is inherently a property of the kite. But remember, you cannot just say that angle ADC. All right, let's get a pen up. You cannot just say, and again, I can't write on this, but you can't just say that angle ADC is equal to angle ABC because it's a kite. You have to, in fact, show it with a proof, right? They also ask you to prove that the diagonal AC, which is that diagonal between your equal sides, prove that it bisects the interior angles. Again, it is a property of the kite, but you need to prove it. You cannot just make a statement. All right, so let's get straight into it, proving that ADC, the opposite angles there, are equal, ADC and ABC. All right, so let's have a look at our diagram. We look at triangle, and I'm going to try and draw on this. I'm not sure if it will allow me to. It does not. But you've got triangle ADC, and I know you all can see that on your screen, and you've got triangle ABC. I'm going to prove that those two triangles are congruent. Now, that's usually, you know, with the amount of information that we've got here, that's usually the simplest way to prove that those angles are equal, because you have quite a lot of information about the sides of those triangles. Remember, in congruency and in similarity, it's important to keep the order of your sides correct, and it seems like it is not letting me write anywhere really. So let's see. Well, you know, it is the first day back of the term. Hey, so everything must not work. There we go. So we're going to say in triangle ADC. All right, and I've got to find a place where we can really work this out, guys. So I seem to have a little spot here. Okay, so in triangle ADC. No, I'm not having any luck here, AB. There's nowhere on this board that I can actually write anything.
Okay,
no.
go to your left, far left. I think it's better when you on your far left.
Far left. Did you see?
Oh, that's
it
your
doesn't
left.
stop. This is my right. You mean my other left?
Yes, your other left.
No, it seems like the only place I can write is literally in this little section there. So no, that's not going to work. There's absolutely nowhere that I can write on this board with any kind of continuity, guys. So maybe let's just talk
Let's
through
just
the
take a
proof,
break and
or,
let's try and fix that for you.
or let's try and fix it. Yes,
Right, cool.
good
My
idea.
sisters, you still have got that chance to do the challenge question and also the test yourself questions. See you after this break. Welcome back, guys. Now, just a quick reminder about what's happening. We've got the notes, and on the notes, you do have the test yourself questions. And on those test yourself questions, if you get to answer them correctly within this week up until 8 a.m. tomorrow, on Monday next week, you could get a chance of winning. You stand a chance of winning this awesome Casio calculator. Remember, the closing time, it's 8 a.m. next week on Monday. So you've got that chance from now on. Remember also, guys, that we do have the More Maths, which is a Nokia app. All you need to do is to go to More Maths, momaths.org, and your code as grade 10s is 2FB5. 2FB5. But now, without any waste of time, let me look at some of the comments that we have on facebook.com/LearnExtra. Remember, guys, you can also follow us on Twitter @LearnExtra. Well, we do have Nero Smith who's saying, thank you to Mindset. You guys have made it possible for me to obtain those marks. Thank you very much to you and Natasha as well. That is Gift Smith saying thank you so much. So Natasha,
AB, I'm going to come over there because I think that there were a couple of guys who had some questions as well.
Yes.
All right. So we had a couple of questions. Someone was saying here that what is the difference between a rhombus and a square? So I did explain a little bit before we went for an ad break and after we did question 3. Remember that a square is in fact a rhombus. So in fact we have that all 4 sides are equal. But the special thing about the square is remember that all of your interior angles are equal to 90 degrees. So all of the properties of the rhombus are still applicable to the square, but the special property to make it a square is that the interior angles are equal to 90 degrees. What other questions do we have here, if any? AB?
All right, there's a comment. Okay, that question was from Karabo Mtaung. Thank you for that question. We have another comment from Teddy Mapi to say, wow, I got 99% in physical sciences and 96 in life sciences. So thank you to Mindset teachers. Wow. What about maths? What about maths? We want to know also on maths, how much did you get? I'll ask that question from you guys, but let's look at some of the questions that you guys have on the page. All right, there was a mindsetter who said, can you please repeat the SR is equal to PQ?
All right, so that was on question 3. Unfortunately, we don't have the diagram up, so it's a bit difficult for me to show you guys. But remember that with that question 3, you had that there were 2 sets of equilateral triangles that were given. And because you had a common side between the 2 triangles, I think it was side PR, because that was a common side, therefore it implied that all the sides in that quadrilateral, which we later on proved was a rhombus, so all of those sides were equal to each other. So that's how come we got that those 2 specific sides were equal.
All right, while we're still talking about that, Natasha, some mindsetters were asking that what is the best way of understanding or practicing mathematics, especially at grade 10?
Well, you know, at any grade, really, Abraham, and everyone else at home, at any grade, it's all about practice, practice, practice. You've got to practice as much as possible. And obviously, you know, we say this always just before exam time, but it's applicable through tests and all the rest of it, is go through past papers, go through past test exams and that you get from previous people that were in grades 10. Ask them if they've got the exams. Go through those past questions, and that's really the best way to prepare for maths, is just to practice, practice, practice. And I always say maths is like golf. The more you practice, the luckier you get.
Nice one. Well, I think for the challenge question, we're just going to post the answer for the mindsetters, but I do encourage them that they should do the challenge question, because it doesn't help you just getting the answers. We want you guys to get involved and then to do these things practically. So, but I think we should end it there for today.
Yes, great. Thank you so much, AB. Thank you guys for tuning in. I hope you understand and look out for that answer to the challenge question.
Awesome. Thank you so much, guys. We love you, and it's great having you guys back on this, and all the best for this term. We know that you guys are going to make it. We believe in you, but also do yourself a favor. Believe in yourself. We love you. Peace.